Okay, can you hear me? Can you hear me?
Yes, sir. Yes, sir.
Okay, I share my screen. So actually here the network problem is very slow, so I simply share my screen. Can you see my screen?
Yes, sir. Yes, sir.
Okay,
Now we can see.
okay. So now,
Sir, before starting, like I want to I have some like queries. Like, what about like overall accuracy and user accuracy and producer accuracy,
so
something like that.
it is
I
the
just want.
totally statistical class. So confusion matrix, then how you can easily calculate the confusion matrix, and this is the different statistical classes. So in this time it will be automatically downloaded. So in this time you can see this is the overall accuracy, and in this accuracy you can see here there is the no. So suppose this is the 0, it means this is the water body, okay, water body, and 1 is the urban, 2 is the vegetation, 3 is the bare land, okay. So if there any error, then you can also see here the this 0 is only for the confusion matrix for the water. So in this time here you can see this is the 0, it indicating only for the 5, okay, and other feature it will be not messing, okay. So that's why you cannot, you can see here the 0, 1 urban, 0 2 then হচ্ছে urban, then vegetation 0, and the bare land also 0, okay. And then you can see this one it indicating here the urban, okay, this is the urban. So here you can see the urban value is 8, and other feature or other classified area just water, vegetation, and bare land will not mix with urban, okay. So here you can see this is the 000, and if you have some error, then we can get also some number of pixel value, we can see here the
Numbers.
numbers, okay. But in this time this is the totally 100% accuracy, so that's why we can get all of this actual value. You can see this is the 3, this is the 2, this 2 means that here you can see this is the vegetation, okay. And this vegetation pixel value will not be mixing with the other pixel values, just
Other.
0 1 3, okay. And this is the 3 we can get only for the 5. And if there any mixing, suppose you want to take for the urban, but your point will be take place on the water, then you can get the some error matrix, okay. Then your overall accuracy will be 80%, 70%, or we can easily calculation this the using a formula, okay. You can simply search the Google what is the formula of the confusion matrix, then you can easily get this, and this is the very equally, you can just write this equation in your in your paper, then you can easily calculate this confusion matrix value, okay. And if you want, you can also calculate the confusion matrix or overall accuracy for each feature. Suppose you want to check what the urban accuracy in this time in here, you can also check it, okay. There is the another formula, okay. So in this time I will try to show you that what is the confusion matrix. You can create this confusion matrix and how you can easily get this all of this confusion matrix value, and after using this confusion matrix value, how you can get the overall accuracy. Overall accuracy means that all of this accuracy, suppose water, urban, then vegetation, bare land, all of this feature accuracy, it will be showing the 100%, okay. Okay, any doubt?
Thank you, sir.
Okay, so now I will try to move to the classified, how you can easily calculate the classified area. So for this classified area, I take a variable, suppose, so you can define the classified area in the many way. Suppose if you want, you can make a chart and bar chart column and define all of this value of the what's the land, or what's the urban, what's the vegetation land. You can easily calculate it in a hectare format or other unit, what square miles or meter square, okay. I want to use here the calculate the all of this feature as a hectare unit. So I just simply make a chart, all of this feature bar chart, I just simply bar chart. So I simply take a variable, make a variable name is chart, and then I simply use here the UI chart. I want to make a chart and also calculated the all of this area. Okay, UI chart image by class. Okay, by class, and then I put all of this argument one by one. So in this time, first of all, image. So this value, this keyword value is that classified image. Okay, so it comes from the classified image, but in this time I want to calculate it the area. So when you calculated any area from the pixel value, so this is the pixel value. Okay, I want to calculate the value from the pixel, then you must be use here the earth engine image dot pixel area dot pixel area. This function you want to use, and you can see this function unit is square meter. So I want to check it from here, ee dot image dot pixel area. You want to see this is the square meters. Okay, this unit pixel area unit is a square meter. So in this time I use here this image pixel area. It means that it calculated our in square meter, but I want to convert in the hectare. Okay, so just I multiply with here, multiply, use the multiply function and multiply with the 1e inverse 4, 1 into 10 inverse 4. Okay, just I multiply it, then it will be easily convert the square meter from the hectare. So now you can see here I want to add here my bands. So in this time I want to add this band. So I want to add this band. Which band I want to add? This is band is the classified image. So I simply copy this classified. Okay, this is my classified image and I want to add this. So I want to add this. So I simply use here the add bands function and I simply paste here my band name classified, and now I want to rename it, or if you want, it's totally depend on you, just I rename it. So I just rename it and give a new name. This new name I want to give, this new name is the classification. Okay, and then you can see here I use here the classification and rename it and use the classification man, and then I also add here the another argument. This argument is the class band. So here you can see here I already renamed my band name. So I add this classified, it will come from my classified image and I rename it classification. Okay, so in this time, in this the class band will be the name is the classification. I just simply copy this classification and paste here. This is the keyword for the class band, and region. So region, I simply put here the region is RY. Okay, reducer is a statistical function. I want to, in this time I want to calculate it all of this pixel value, total of this pixel value I want to calculate it. Suppose I want to calculate it for the all of this pixel value for the urban, I want to calculate it for the all of this pixel value for water, I want to calculate it for the all pixel value for vegetation and barren. Just I simply use here the ee dot reducer dot sum. Okay, it will be calculating sum of all of this. So scale is the resolution of 30 meter. I just simply put here the 30 meter, and class levels. So class levels is the legend or the x level value. So I want to make a bar chart. Suppose I want to make a bar chart for water, I want to make a bar chart for urban, I want to make a bar chart for vegetation, I want to make bar chart for barren. So class levels, I just put this name easily. Suppose first is I want, you can see it according to this. So first water, I simply put here the water then another is urban, I just put the another urban, then vegetation, I simply put here the vegetation, okay, then another bare land, I simply put here the bare land. So this is my X level and it indicating the is bar land, okay, is chart bar chart for the water, urban, vegetation and bare land. And X levels, in this time this X level is not needed, I just remove it, okay. And I want to print this chart, so I want to print this chart, simply copy the chart and paste here. So just click on the run. So it will be generating this chart. Here the network issue, so it takes some time, but it will be you can see this is our chart and this chart is not the meaningful. I want to get some, I want to also make this chart according to this legend color. I want to use here the bare land for the yellow color, urban I want to use for here the red color, and water I want to use for here the blue color. So for this I want to add the some specific function, and we already know that when you add the sum title X level Y level, then you use here the set option function, set options, okay. I want to simply put here the title, I just put this title, this is the Dhaka city classified area, I just randomly put this in hectare, okay, sorry, hectare. And then I also use here the horizontal axis and gap this is the title, it is the classification, I just simply put the classification. And then I use here the vertical axis will be, I just put here title, and this title you can just put here the area, it represent the area unit hectare, okay. And then I simply use here the colors, so these colors indicating our the bar chart color, bar column color, just I simply put here the first color, first is you can see water, I represent this water bar column as a blue color, I just put here blue. Then urban, it bar color red, I also put here the green, okay. Then I put here the where yellow, okay. So now you can see here, I just simply click on the run, okay, syntax error, why, I just simply use here the comma sign, then click on the run. So now you can see our legend color and our map chart color will be the same, okay. You can see I just simply click to here, now you can see all of this value, water how many water available in this time of 2021, you can get this result from here, every feature, okay. And you can also see this is the classified image, and you can also make the confusion matrix, and here we can use the to classify random forest. When you use the random forest, you must be use here the decision trees, and decision trees number it different way. So in this time I simply use here the decision tree number is the 1000, and I can get this result, okay. So I also try to show you that how you can easily export this map as a TIFF format, how you can define the data for the training set and test set. So any question in this time in here? And I also provide you this full code so that you can practice. Okay, any question?
Sir, how about the table or the area, in table? Can we draw that?
Do you want to make this area calculated in a table?
Yes, sir. Yes.
Okay, you can always easily do that. Just you can see here, just download the CSV file. Okay, it will be downloaded the CSV file of this area as Excel file. You can get this, and with this data, okay, you can get the chart data. Suppose urban, you can get this data. Just you can get this data in a Excel format. Okay.
Oh, okay. Thank you, sir.
And you can also download this from the download the PNG, then it will be saved as a PNG file format picture. Okay, or any question? And you can keep practice 2 or 3 times all of this code one by one. I hope you understand this.
Yeah, we understand, but I have some questions.
Yeah.
How do actually how can I do it for any crop? Because
So,
okay, because in vegetation there are many crops.
Yeah.
Suppose in a season,
Yeah.
in a season, there is vegetable, there is suppose in Boro season in Bangladesh, there is vegetable, there is wheat, there is rice, and there is maize and other many crops.
Yeah.
How can I differentiate the area
So
in this situation?
first of all, you want to take this ground truth data, and I also try to show you this the previous project so that you can easily understand. So in this time here you can see the Bro season 2021, all station of the Bro season. Just I want to make this point, training point, and this point will be take from the ground truth data, okay, from the different district of Bangladesh, okay, and just you want to use this point as a training data set, okay. First of all, you collect the training data from the field, okay, then make a shapefile, okay, then you can use this training data set as a feature collection. Feature collection means that here you can see when I get the training point for water urban, I can simply use here the import as feature collection, okay. You can, when you upload it, I will try to show you that. Suppose I want to make a shapefile, you can see this is the add property, okay. So when you import this point shapefile, you can just simply add this add property. Here you can see property and value. Suppose first of all you want to take the ground truth data for the rice, okay, you can make a shapefile for the all of this rice point, okay. Just you can make this property, your property value, class or what you want, just a variable, and get this value. Suppose I want to get this value for rice field 1, I just put here the 1, then upload, click to upload, okay. And after this, when you use this training data set, you not take the training data set from here, you just import this point in here. Suppose in this time, this point, I simply import this point, and now suppose this is the rice. Suppose you want to rice and non-rice, you have the two training data set, rice and non-rice. We can classify the rice and all of this feature, what will be urban, land and other feature, I want to under the non-rice. So I have the two data set. So then I just put here the rice. Suppose this is the rice and this is the another things for the non-rice, okay. Just I put the another data set, this is the non-rice. I can get these two data set, and then I can do for the same process. I need to the create the training data, need to the training the merge, I can get the training data set, overlaying the points on the image, the training data set, okay. Then you can guess the train set and train set and test set. Then you can use the random forest or the classification regression models, okay. Then you can get all of the same things.
So what in the ground truth data?
So
What data I can?
you can ground truth data take from the specific latitude and longitude. Suppose you can go to the field and then you can easily take from here the latitude and longitude from here and put this latitude and longitude just a excel file, and you can easily do it using the arc map. So you can easily using the arc map you can convert this x file csv file latitude
No,
longitude convert
I
into
know
point.
that, but can you show a sample?
Sample means
Sample means data. Which data I need to take from the field?
this is the
Just I can.
geographical data. It means the actual location of the field.
Okay.
Suppose in this case you can see this water. I want to check here from here. Okay, you can suppose I will try to open a new code editor. You can go to this field and just you can calculate the actual location, latitude and longitude of these places. Okay, suppose in this time I just simply click on the here, I can get the special latitude and longitude. Okay, and now I want to use this latitude and longitude anywhere, and I can get this place, a specific place I can get from here. Suppose in this case here you can see the all station bureau in Bangladesh 2021. Here attribute table you can see this is the only for the latitude and longitude, okay, of this the field rise, lat and long.
Okay.
Then I can convert this lat long in the point shape file. Just import this. Okay.
I just want to know what is max March long, mean December with what is max March long in your data?
Max
March
okay.
long.
Okay.
Long and minimum December.
This
No, not this one. In your data set, just what you were showing in Borosen, yes.
Yeah.
Then in the shape file, maybe.
Yeah, this is the shape file. This is the point shape file.
Yes. What is this data?
This is the attribute table. Suppose here you can see this
latitude,
is the
longitude.
This is the
I want to know.
Noakhali. This is the
Yes.
specific place of Noakhali, and this is the latitude and longitude of this rice field.
I understand, but what is the max March long data and
okay,
minimum?
I understand. So this I think this data has also another attribute table column. Okay, this is the another, but it is not focused in this time. Just focus with the lat and long, and this is the another. Okay.
Okay.
Okay. Anyone any question? And you can do any classification using this procedure. Just you have to know the ground truth data. Just you can import this ground truth data. How I try to show you that when you import this shape file, just you can add the property. Okay, this is the property and value. Just put this. It will be ground truth data, rice field or other field. Okay, so
okay.
recently we will work for a crop classification map for the Punjab. So I will try to find out this. here the network is very slow this time. I think this code has some error. Okay, so any question in this time in this code, and I will provide you this code so that you can easily practice, no problem. Any question?
Sir, I have one just quiz. I just want to know, like, when we are taking the training points,
Yeah,
for example, barren land and sometimes the vegetation are not clear. For example, let's say to vegetation and like different band for like agriculture or barren land.
yeah.
Can we do that?
So when you get the image, you can get actually when you use the satellite imagery for taking the ground
Mm-hmm.
truth data, then you have used the different types of band combination. Okay, and I already show you that how you can easily do the band combination, and you try to use the high quality resolution of these images. Okay, so that you can easily identify this feature. Okay, so that's why that's in this time Google Earth Engine the provided the Sentinel-2 12-meter resolution, and that is the very easy, you can easily understand. But this satellite imagery is not the it will be start from the 2013. Okay, so previous years you want to use the Landsat classification, then it will be very okay. Or if you have the any ground truth data for the present time, then you can use this easily, and your accuracy also be more high when you use the ground truth data.
Okay, so that means we cannot we should work on the same like band, right?
Yeah,
For the different. Oh, okay. Thank you, sir. Thank you.
So I will go to my next slide. So actually in this time I will try to show you the full LULC map in Google Earth Engine, but it is the first time I will try to show you all of these things, because this is the introductory part, so that's why this class will be very long. Okay, when I complete the full LULC one by one, then it will be take the long time, and so that's why, and this in this first time I will try to show you the full course of the LULC in the introductory part. Actually I have another course for the land cover classification with the all using the all of these classifier, using the all of the classifier with their you can also know from the all of this data structure of this classifier and machine learning. So in this time I will try to show you the all of these things using from here, so that how you can easily use the random forest as well as the classification and regression trees. Okay, I hope you understand these things. Okay, I will go to my next slide. So in this time I will try to show you that how you can computation using the satellite images. So in this time I will try to show you that how you can easily calculate the this type of equation using the Landsat band. Okay, so you can see here NTVI. So I will try to show you a randomly example so that you can easily understand. So first of all, suppose I want to take a place. I want to take a place for calculating the NDVI. I randomly put a suppose I want to randomly take a point. I want to get this point tiles for calculating the normalized different vegetation index using the band calculation. So I just simply use here the point, then I simply put here the Landsat 8 top of atmospheric. I just simply import these images and I simply change it L8. Okay, and now I want to filter this image collection, and I already know that how you can easily filter this image. I just simply use here the image variable, and then I simply call the whole collection, and then I want to use here the filter bounds so that it will be intersecting with my point, okay, point, and then I simply use here the filter date function. Suppose I want to calculate it the year of NDVI, the year of 2015, 1st January 2015 December 31, okay, and I want to sort this image collection, the properties of cloud cover, and I can get the first image of this year, okay. So you can also do for the another for the filtering the image properties. Next, previous time I will use here the filter metadata. If you want, you can sort your image properties, or you can sort your image properties using the cloud cover. I just simply use here the cloud cover, image properties, cloud cover, okay, and I can get the first image, which image will be taken between this time, okay, 2050, year of 2050. I simply use here the first, okay, and you can see here I want to show the image information, so I simply use the print image. So here you can see this image only for one image, and this image have the 12 bands, and also check here the properties, all of these properties of these images, okay, and I can get the first images between this time sorting with the cloud cover, okay. So now I want to use this image for, you can see the image date 2050 January 28, okay, it will be taken in this time frame, and then I want to calculate the normalized difference vegetation index. This formula is that NDVI, it will be, this is the 2 band near, and it will be subtract with the red band and divided sum of the 2 band near plus red, okay. So in this time I will try to show you that how you can easily calculate this equation in Google Earth Engine, okay. So for this I want to select my specific band. I simply use here the var keyword, and after this I give a variable. Suppose I can simply use here the NIR, near, and you can use the any variable name, and I want to select this band name. So in this time I select this band name, so I simply use my image collection and kept this band name is that, you can see here the near infrared band name is the V5. I just use here the V5, okay, and then I simply use here the red infrared. I simply use here the red band, simply use the red variable. You can use any variable name, then call my image collection, and then I select from here the red band. I think it will be B4, okay, just I simply paste here the B4, okay. So now I want to use here the many way to calculating the NDVI. If you want, you can use the directly equation. If you want, you can make a function. If you want, you can make a expression. So I simply use here the equation. First of all, I want to try to show you the equation. So I just simply use a variable of NDVI, and after this I want to calculate near. This near come from this variable near, and it will be subtract with our red band, RED, red band, and then it will be divided by the 2 of the sum of the 2 bands. So near it will be add with red, okay. Just I put this equation, okay. So now I want to show this result. I simply use add the map dot add layer function. I put here the NDVI and click on the run. okay, I can get a result, but this result is not proper because I want to add here the visualization parameter. Suppose I make a visualization parameter, I simply use here the ndvi vis, okay, then I make a dictionary. I want to get only for the pixel value, it will be start from the -1, and then is the max pixel value, it will start from the 1, okay. And then I also define here the color plated. I make a list and I want to show the result which will be -1, it will be showing the color of the blue, okay, I just simply the blue, and greater than -1, less than 1, I want to show this result, it will be white color, okay. And then I want to show this result for the dense vegetation which is indicating the pixel value 1, I just put here the green, okay. So now I want to add this vision parameter with my ndvi, just put here and simply paste the vision parameter variable name, just click on the run, you can get this result from here, okay, it will be appeared. If you want to check this result from here, you can get the positive result, and when you simply click on the you can get the negative result, okay. So this is the one way for calculating the equation, or if you want you can also use the expression function. I will try to show you that. For this you can select the band like this, and after this you just put a variable, this variable name is ndvi, and then you call here, then you simply call here the variable name. Suppose I simply put here the variable, it is my image collection, so this is my image collection,